I'm just going to explain how to start up with your device and how you should communicate with your Pycom device in the best way. And just to mention what I have here, this is the battery holder. I do recommend that you at least get any of these during the way. It's a pretty neat thing if you want to take your device and try it without having it connected to a USB device. And as you can see, I have a little switch here which makes it easy for me to switch it on and off. Should also mention that this is a JST connector, pretty common for small drones and also remote controlled cars and such. You can find this connector. So it's JST connector, and you'll find it in the documentation. There is a lot of these ready to use assembled battery holders. You can buy one with 2 batteries or 3 batteries, or it should work even with 4 batteries, as there is a built-in voltage regulator in this. I should mention as well that the expansion board has a built-in charger, LiPo charger. So please, if you're not using chargeable batteries and are not a LiPo battery, you should have a switch so you can switch it off, because otherwise when you plug this in, the expansion board will try to charge the batteries. Otherwise, this is the LoRa antenna. I'm not using a Wi-Fi antenna. It's often not needed. If you're not too far away from your Wi-Fi router, the built-in antenna should work fine. But yeah, you have the possibility to add a Wi-Fi antenna as well to this device. So what you need to start with is to choose either if you want to use Atom or Visual Studio Code. I've covered this in a couple of sessions before. My preference is Atom. I know that a lot of people prefer Visual Studio Code, but just choose any of these. And I'll start up my Atom IDE. And as you can see now, I'm just going to show you around. I have actually very simple code running on my LoPy now. What it does is that it's just changing color on the LED and it's looping around. As you can see now, I have my projects over here, and this is important when you're working in Atom or Visual Studio Code. It's the equivalent in both of these programs. You can work with several projects simultaneously. You can have them, as you see here, I have one project called CS811 BMP280. I've been playing around with that. And this one is empty, so it doesn't show anything. There's no files in it. You can go and just add a project folder. If you do this, you'll get to the Finder, or in Windows you'll get to the Explorer, and then you can just add whatever folder you'd like. Open that and you will get a new folder here. So if you work with several projects at once, this might be a good way of doing it. You can also just remove project folder. This does not mean that I'm deleting the folder from my hard drive. I'm just removing the placeholder here in my sidebar. if you want, you can just hide that one if you think that's easier. What is important is the PyMakr plugin. And if you haven't found it before, you will find it if you go into the settings and then just search for PyMakr, and now this one is already installed, so you can see if I have it here. When you have the PyMakr plugin, you will get a new window at the bottom of your Atom screen. And this is the REPL interface, which means that you are actually directly connecting yourself to the Python interpreter, which is running on board the Pycom device. And this is one of the neat things with the with this device. The structure of the MicroPython code on these devices are very, very simple. Everything you write in a text file is a .py file, a Python file, and it first boots up, and then it starts the boot.py file, and after that it starts the main.py file. That's it. Obviously you can put your own, it's a file system on, it's either little fs or it's fat, but you can put just any structure you like on board. So just to show you a little bit on how this works, you can turn this on and off. If the device isn't found automatically, go into the global settings. You can, in certain cases, I've found that if you disconnect, auto-connect on USB, it might help, and then manually trying to edit the address which you're using. There are some options, safe boot before upload. In my experience, you should have that crossed. It takes a little bit longer every time you upload code, but in my experience, it works better. If you press run selected file, I have no file open up here, then it will just run that file. Then you have upload project to device and download from device and get device info. So you have a lot of different options here. If I press get device info, you'll get the LoRa ID, Wi-Fi mode, Wi-Fi AP, and so on. And in this case, it has Wi-Fi up and running, as you can see in station mode, and the IP address is shown here. If I now press download from device, I have a little button here which I can use if I have several projects open. So let's add another project. I'll add cat M1 project. And then you can see that I have two to choose from. Session 2, which is the project which I have in mind working on now. That's an empty project. And I'll press download from device. What I'm doing now is that I'm downloading the files which are on the Pycom device down to this project folder. And it's now asking me, found 3 new files. Do you want to download these files into your project? Yes. I can choose to just download new files or overwrite, whatever. And as you can see now, this is flashed with the Pycom PyBytes firmware, so it's automatically connecting to MQTT to the PyBytes platform as I did earlier. Now this is an infinite loop I've started up. It's going to flash these colors over and over and over again. if I want to break that loop, you can always press Ctrl C, make a keyboard interrupt. Hopefully I'll break that loop. Yeah, it looked like it worked. You can see here there is nothing in my boot.py. You don't need to put anything there, but often when you work with that, you might want to have your network connected before you run your main code or any of that, then you might put those things in the boot.py file. Otherwise, you'll find the code, main program code, in the main file. And just to mention, the pybytes config JSON file, that's the configuration file which is used when you use the pybytes platform. So that file contains information about your Wi-Fi network, for instance, and also the information to, well, where your device is going to send data into the pybytes platform. So that file should not be shared, and it's plain text with a lot of information that might be or might not be sensitive depending on the situation. But that's about it. You can see that I can execute code now directly on the device, and these things are what makes this so powerful. If I now want to just switch project, I can look at this project, and here I've been playing around with the LTE. This is not a PyPy, so I will probably have it will probably give me some errors, but we'll try to upload this one. And as you see here, I have the cat M1 upload project to device, and when I upload a new project to the device and this project contains new files, it will automatically just overwrite these files with the new project files. And just as I said, you can see here that in the debug field here, the output from my interpreter is that cannot import name LTE. And the reason behind this is that this is a LoPy, and actually I could probably have imported LTE library even on a LoPy, but because this LoPy is flashed with the LoPy firmware, and in the firmware file, the file that you use when you flash your device is different for different versions of the Pycom device. Obviously, this does not contain the LTE library. So that's short about your setup, and you should be pretty confident using the Pycom upgrade, because sometimes you need to know how to, well, switch the firmware. And we are going to be using the PyBytes firmware for the first examples, just because they already have a platform which is pretty neat to get into. But you might want to use the legacy firmware if you're going to build on a project which contains which is as much MicroPython standard as possible. The legacy firmware does not contain the PyBytes libraries. So I'm just going to flash the newest legacy firmware. And I took now erase during upgrade, which if you don't do that, the old code will actually still be on the device, which might be or not be a problem. You'll notice it very soon after. Anyway. And now we're erasing, and let's see what happens. Just to note is that when you're flashing, well, obviously it won't work anyway, but close Atom before you do that. So you only use the USB port for this particular purpose. So one at a time. And let's see, now it's done, and I have now a lot of information about my specific board. And let's go in and open Atom and see how this works. I'll just remove the bytes JSON file, and then we'll upload my code for just changing colors, and it seems to be working very good. And as you see now in the terminal here is that we have now the Pycom MicroPython 1.20.0 release candidate 13, released August 2019, which is now the newest version that you can get from the Pycom firmware updater. I should mention as well that you can just create a new file if you want to start a new file. My cool function.py. If you name it .py, the Atom editor will automatically understand that, okay, this is a Python file, and it will format the text and also help with white spaces automatically. And this works the exact same way in Visual Studio Code. And when you structure your project, the way you should be doing it, if you have a library, and when I'm talking about library, is that you might import a sensor library. So let's say that you have a specific sensor which you have downloaded the library from GitHub or internet or somewhere, and you want to structure that in your project. You should put that under the lib folder. If you then want to import something, I'll just make a new file, sensor1.py, and I can write my sensor library here. When I want to import that, I just have to write import sensor1. That will import this sensor library. Either I just write import sensor1, and then I can use that for later on. I have to write that. Or I can actually rename it as sensor1 as if I think that's a good way of doing it, I can do that. Or if I want to import a specific part from my sensor library, I can write from sensor1 import my cool sensor, and you might have a function within that library that you can import in this way. So this is more or less just a brief introduction on how you should be working with Atom, how you should be working with the Pycom device, making it as easy as possible. I recommend that you start with the PyBytes firmware before you go on to the legacy firmware, but it should not matter for the basic examples. And the only difference, as far as I know, is that the PyBytes firmware contains PyBytes libraries which are specific to the PyBytes platform. But if you don't want to play around with that, that's really not needed, and you should go with the legacy firmware as I see it. Stop recording.